Hello, wonderful people of the universe. Science is all about understanding Mother Nature. And technology is about taking that understanding and applying it to better our world. As we know, that plan doesn't always work. In this series, we want to open people's eyes through various experiments, not unlike the late, great Julius Sumner Miller. And like him, I'm going to ask you to consider the following. So today's topic is going to be about air pressure. We live on the sea floor of an ocean 10 kilometers deep of air. So if you travel up 10 kilometers, that's how much air is resting on the surface. And that air has a weight. So that weight is exerted 14 pounds per square inch, or 101,000 newtons per square meter. Now, we need to visualize that. What does that feel like? What does that look like? Because we can't actually feel it because we're accustomed to it, and it's from the bottom, it's from the top, it's all around, it's from inside us as well. Everything's equalized. But we want to try and visualize it without that. So I take this skewer, wooden skewer here. So what would you expect to happen if I put this wooden skewer on the table and with a quick jab just hit it like that? Okay, you'd expect exactly what happened. It flew up. Nothing happened to the stick itself. Now, I take this piece of paper, which is 40 centimeters long, 30 centimeters wide. So that exerts a force through the air of about 1 ton straight down on that piece of paper from all directions, so the paper doesn't do anything weird. But when we put it down on the ground and we try and flatten it out, the air, we're going to try and get the air out from underneath it, so the air is just pushing on top. Now, if we put that down there, spread all the air out, and then we give it a sharp hit, a much different effect happens. Alright, so now we're just going to talk about a very simple thing, a suction cup. Maybe shouldn't be called that. It's not a good word because it's not really a suction cup. There is no such thing as suction. What happens is when I pull this suction cup out and it moves in, you're increasing the volume under that cup. So the air pressure underneath is less than the outside. There's less particles per volume on the inside than on the outside. So the actual force is not produced by the suction, it's produced by the air pressure outside, the difference. The air pressure is what's pushing behind it. So let's see how a suction cup works to lift a heavy weight like this photo frame. So put the suction cup on and we screw it down, which is lifting that suction cup up. So now the air pressure underneath the photo frame is what's going to be lifting it. I am not lifting the photo frame directly, I'm lifting the column of air above the photo frame, and as a result, up comes the frame. Remove that diaphragm lifting up so it's flat, and then it comes off. So here we've got a similar demonstration except opposite pressure. When you drop an object onto a table, a flat surface, it's quite loud. You hear the sound of it drop. Now, if the two objects were quite flat, you would get a different result. So here, this big, much heavier flat surface on this flat table, it's a lot more of a deep thud, and you can really feel the air push. It's a lot more pronounced if this was a big pane of glass. It would just really come softly down onto the surface, and that's because underneath it you have a build-up of air pressure. The air can't get away, and on top the air pressure remains, so it slows it down. And people who are working in the window industry will do this all the time. They'll get a big pane of glass, they'll put one down on the floor first, and then they'll just drop the remaining ones on it, and then they won't shatter, they'll just slowly pile up, and it's the same effect. You have this air stream underneath that can't get out of the way, and it builds up pressure, and that pressure dampens it, because of course air is compressible. So that's another example there. Thanks for watching, guys. I'm Tech Iman, and remember, keep pushing the boundaries.